that every single time someone asks you how many foot-pounds are in 642 kilowatt hours, it takes you, maybe a minute or two to think of the answer?
What?
You know that happened to me just the other day.
Huh?
Martha, we're kidding.
Oh.
But the point is, though, there are so many ways to measure things that nobody could possibly remember them all, or nobody would want to. Beyond the ones that we just use every day, you just simply have to look them up. Now, I want each of you to have one of these little reference books, all right? Would you pass these around, please? Now, this little book contains several pages of conversion tables, and you can go from one unit of measures to the other. Now, it also has several common formulas and examples of how to use them.
This will be helpful.
Yes, but for this class, I want you to have one conversion chart that you can carry around in your head.
You know, Frank, I don't have any problem when it comes to the common measurements like feet in a mile or quarts in a gallon, but sometimes I just can't remember how to get from one to the other.
And that is exactly why you need one formula to do it all.
Just one formula?
Well, let's have a go at it. Now, here is one conversion chart that everybody knows. 1 foot equals 12 inches. Sue, can you make a fraction out of that?
Well, it could be 1 over 12.
You mean like this?
Mm-hmm.
Now, I am sure you all know all of the meanings for this expression. If this means 1 foot equals 12 inches, then what does this mean?
Well, 3 feet equals 36 inches.
And this?
4 feet equals 48 inches.
It's a simple proportion.
Sure it is. Well, I got through proportion. I guess I'll get through this.
You know, if the world has been looking for a system for converting one standard measure to another, this is it, proportion. And it has more applications than you can possibly imagine at first. Now, suppose you wanted to convert gallons to quarts. Now, look at this.
Would you write that 1 over 4?
Yep. And then you would be set up to find out all you would ever need to know about that relationship. Now, suppose I had 75 quarts. How many gallons?
You put the unknown, what you're trying to find, gallons over 75.
You mean like this?
Right.
Uh-huh. All right, now somebody tell me in plain English what this means.
Well, that means that if 1 gallon is equal to 4 quarts, then a certain number of gallons would be equal to 75 quarts. All you got to do is cross multiply, and you got it. Almost, just about.
Now what?
Well, you'll have to divide both sides of the equation by 4.
Like this?
Right.
Uh-huh. All right, now what is the one important tool, one important thing to remember when you use this tool?
Well, you've always got to put the same measure in the same place in the fraction.
Now, what do you mean by that?
Well, if you put gallons above the line in the first fraction, then it has to go above the line in the fraction you're converting it to. Did I say that right?
Well, I understood it perfectly. How about the rest of it? Yeah? All right, well, we'll work a few more of these, all right? Now, just remember what Sue said.
What did you say? Put the same kind of measure in the same place in both fractions.
All right? How many ounces are in 7 pounds? Well, you're all doing very well. Now, regardless of what the numbers seem to say, do the same thing. How many miles are in 880 yards?
But I don't even know how many yards are in 1 mile.
But you can look it up.
Here it is. There are 1,760 yards in a mile.
Great. So then I'll write the original fraction as 1 over 1,760.
That's it.
Okay. There aren't any miles in 880 yards.
Really?
Well, look, I get 1760x equals 880. So then what?
Well, you do the same as before. You divide both sides by 1760.
Okay.
1760x divided by 1760 is x. 880 divided by 1760 is 1/2.
Oh, you're right.
880 is a half a mile.
So, you see, it works for fractional conversions as well. Now, you perfect this system, and you've got a winner.
It'll change some things between the two systems, too, won't it?
2 systems? What's he talking about?
Well, we've only been talking about the English system so far. There is the metric system, too. And measures for length, width, and volume can be converted from English to metric and vice versa by using proportion. For instance, 2.2 pounds is equal to 1 kilogram. Now, if I set it up like this, then I can figure out all of the pound-kilogram problems.
Well, let's do one.
All right?
Okay.
All right. How many pounds are in 56 kilograms?
I get 123 2/10 pounds. You know, Frank, since I've been in this apprenticeship training program, I've been doing a lot of measuring, and I found out that measure is pretty easy as long as you stay in the same system. It's when you go from the English to the metric or in the other direction that you can run into trouble.
I think that's true. A lot of people are fearful of metric, but if you use only that language, it's very simple because it's decimal. Well, maybe we'll have a chance to discuss this system later.
You know, I've got an exception to the proportion system. Temperature.
Right, right. To go from Fahrenheit to centigrade, you have to have a special formula. But it's right here in this little book. Most people don't bother to remember it. They just look it up whenever they need it.
As long as we're talking about measuring, you know what I think would be really helpful?
What's that?
When I go to a store and I see that they're having one of these big discounts, I can't tell if I'm getting a good deal or if they're just ripping me off.
I know the feeling. You all familiar with it? Can you give us an example?
Yeah, the other day I was buying some shampoo. Now, my brand always sells for $1.09, but the store brand cost only 89 cents. So,
Okay, now that's a start. Does anybody want to ask Nancy a question?
Yeah, were the bottles the same size? I mean, did they hold the same amount of shampoo?
I think so.
Well, but then you still don't know about quality. I mean, I'm pretty fussy about the shampoo I use.
You know, Martha's got a good point. If they're equally good, then the store brand is cheaper, provided they're the same concentration.
Well, then you're worrying about quality, but I'm talking about more than that.
Okay, what else?
Well, they advertise this large economy size. Now, it costs more than the smaller size, but it has more shampoo.
Well, at least in that situation, you know about the quality.
Well, now,
Yeah.
this is a good discussion, but we need to know some other things in order to do a comparison.
Well, if you knew the sizes of both bottles, you could work it out.
How, Sue?
Well, if the $1.09 bottle was 8 ounces and the sale item was 12 ounces, I'd work it like a proportion.
Well, come up here and show us.
Oh, okay. Well, you could set it up, thank you, like this. 8 over $1.09 equals 12 over X, the unknown.
Does she have it set up right?
Yeah, I think so.
Oh, 8 and 60. Okay.
So, what does that tell us?
Well, it tells us that 12 ounces for $1.64 is the same value as 8 ounces for $1.09.
So, what advice could we give to Nancy?
Well, if the sale price is less than $1.64, then for 12 ounces, then she should go right out and buy that bargain.
Do you ever suspect these stores of putting the same item into a larger package and then charging an even greater unit price?
Oh, yes. Listen, I know they do. I went into the store the other day to buy some coffee, and I found this real good can of coffee, 2-pound can, for $6.40. Now, the store was having a super sale, so they said, on a 3-pound can at $9.87.
So, what did you do?
Well, I divided it into pounds.
I bet you had your calculator with you.
Why, sure.
You know, I think the one thing that Martha has learned from this class is to always have her calculator handy.
Listen, anyway, this 2-pound can, I found out it cost $3.20 a pound. So then I divided $9.87 by 3, and I found out that it cost $3.29 a pound, and that is 9 cents a pound higher.
Oh, no. Well, you can figure out the unit cost, as Martha did. That's the cost per pound. Or you can do it by proportion, as Sue did. But either way, it is a good idea to do comparison shopping. Well, that's all for this time. Oh, I've made up some worksheets for you on measure. You can pick them up as you leave, all right?
Frank, there's been this nasty rumor going around that you're going to give us a big test in a week or two. Is there anything to that?
Well, no, I don't want to commit myself. But can you all measure Todd's fish yet?
We don't want to measure Todd's fish.
Well, you had better ask him about it. Now, that's all I'm going to say. You can threaten me, you can torture me, my lips are sealed.
Well, I don't remember anything about it, do you?
Hi. You should have learned in this scene that proportion can be used to convert one unit of measure to another. Now, here's the way it works. If you know that 1 foot equals 12 inches, a fraction can be made. Or another way to consider it is a ratio of 1 to 12. Once this relationship is set up, all conversions involving feet and inches are possible. For example, to answer the question, how many inches are there in 53 feet, you say 1 is to 12 as 53 is to some number. Then, by cross multiplication, you get 636. There are 636 inches in 53 feet. Note that as this problem is set up, like units are the same place in the fraction. Feet, feet, inches, inches. After you have done several examples, it is a very natural system. Of course, there are shortcuts, but if you are in doubt, this way of converting measures always works. Here are some units in their lowest terms. Oh, by the way, do you remember Todd's fish problem? Head, 9 inches. Body equals head plus 1/2 tail. Tail equals 1/2 head plus body.
What in the world are you up to?
You ever notice when they deliver lumber, they always put the 2x4s where the plywood ought to be and the plywood where the 2x4s ought to be?
Yeah, that's the way it goes. Can I help you with some of this stuff?
Well, you can supervise if you want to.
Man, this is going to be some addition.
Yeah, I think we'll like it. See, what I'm going to do is take out that window, put a glass door in there to the rest of the house. Then we're going to have a vaulted ceiling.
Oh, that's nice.
A brick fireplace right over here.
You know, I wish I could fix up our house a little.
You know anything about bricks?
Well, my uncle was a bricklayer. I used to help him when I was a kid. I remember a little about
Well,
it.
that wall is going to be all brick.
Oh, that will be nice. How much is all this going to cost you anyway? A lot, I guess.
I really don't know. Maybe you can help me figure this out. I've already
okay.
picked out the bricks we want. Here, help me get a measurement of this space.
All right, you know, all we have to do is just figure the area, and
Right,
then
well,
that'll give you what you want.
It's going to be 10 feet across, and the bricks will go all the way to the ceiling.
All right, well, how big is a brick, then?
It's not just a brick you have to consider, though. It's a mortar, too, see?
I forgot about that. You know, my uncle used to say 7 bricks per square foot.
Put that down against the floor, if you
All
will,
right.
Todd.
There you go.
You got that tight?
Uh-huh.
Okay, 13 feet and 9 inches.
13.9, and you're going to
Right.
take it 10 feet in this direction.
Right, so to figure the area, I'll want to multiply 13 feet and 9 inches times 10 feet, right?
Right.
What is that they're always telling us about only multiplying the same kind of units?
Well, you have to express the 9 inches as part of a foot. You know, 9/12, that would be 3/4. I guess the best thing to do would be 75 hundredths.
Right, so it would be 13.75 times 10.
Yeah,
Now they're both feet.
right.
So how's that?
Yeah, you got it. 137.5 square feet.
Now, how many bricks did you say went in a square foot?
Well, now, if my memory serves me correctly, 7.
Okay, well, I can do that as a proportion. You could write it as 1 square foot is to 7 bricks as 137.5 square feet are to some number of bricks.
Right, or you could just multiply it by 7.
Right, be the same thing. Okay, 7 times 5.
How much are bricks these days,
The
anyway?
ones I want are $280 per thousand.
9.
Okay, 962 and a half.
Now, there's a ways, too, you know. It takes half bricks to make a bind. So, let's see, $280 per 1,000 bricks would be 28 cents each.
Okay, so we would multiply the 962.5 bricks times 0.28, right? Yeah, times 0, 0, 3, 577, times 0, 1, 5, 2, 1, 19. Okay, $269.50.
That's it. That's not bad. You know, I'm going to love this room of yours.
I will too if I ever get the thing finished. Did your uncle teach you how to lay bricks?
He sure did.
I'll give you a job.
All right, you got it.
$1.37 an hour.
Hey, can't be that. I can work a lot of hours.
Okay.
You know, Martha, I want to thank you for your help with this canning. I tell you, it would have taken me forever by myself.
I enjoy canning. It's so basic.
Look, how many jars of beans did we get done anyway?
Well, let's see. We've got 4 rows with 4 quarts and 4 pints in each
Okay,
row.
so that's 4 rows of 4. That's 16 quarts and 4 rows of pints. That's 16 pints. We got done 16 quarts and 16 pints.
We could have put it all into quarts. That's 2 pints to the quart. That's a 1-to-2 ratio.
Well, let me see. Now 1 quart equals 2 pints, so 16 pints equals 8 quarts.
That's it.
Mhm.
So 16 quarts plus 16 pints would have given us 24 quarts altogether.
You know, we could have put them into gallon jars. We'd have 6 gallons.
Well, we could have put them all in a barrel. Can you imagine a barrel of beans?
Not to mention a hogshead or even a demijohn.
You can bet I'm not going to mention those. You know, I think I've been doing real well in measure ever since we started talking about it in class.
Uh-huh.
I mean, like now, we converted from one measure into another and then multiplied. But I think addition and subtraction are a lot more difficult.
You know, I think so too, but you've always got to keep in mind your base unit.
Yeah, I know.
You know, I was working on those worksheets that Frank gave us, and I made a couple of discoveries.
Really? What?
Well, first, in adding measure, if you're careful to keep the units separated, you can use that proportion system to simplify it.
How do you mean?
Well, I know that worksheet is in here. Here it is. Now look. You add and you get 8 feet and 25 inches. Now, since I want to simplify 25 inches as feet, the proportion system works fine.
So that gives you 2 feet 1 inch, add it to the 8 feet, and your answer is 10 feet 1 inch.
Right.
Well, how about subtraction, though?
Well, it's only hard when you have to regroup. But I learned something about that, too. Look at this problem. Now, the book says to do it like this. Compare your 28 with 12. Then you decide that you need more minutes to subtract. Now, you have an hour over here, call it 60 minutes. Add it to the 12, and then it's just a matter of subtracting the 28 from the 72 or 44.
Oh, so that's just like regular subtraction when you have to regroup, except that you use 60 instead of 10.
Right, but there is a simpler way.
What?
Well, you don't have to do any of that regrouping if you use signed number rules. Just subtract the 28 from the 12.
That's a negative 16.
Right, then you subtract 1 from 5 and you get 4. So the answer is 4 hours minus 16 minutes.
Oh, that's the same answer.
Well, yeah, but you still have to know that there are 60 minutes in an hour. It's just simpler for me to say 4 minus 16 minutes instead of going around and borrowing an hour and then breaking it up into minutes, then adding and then subtracting.
Sue, you are remarkable.
I know.
Do you suppose anybody else knows about this?
You know, I don't know. You think I discovered it?
Do you suppose?
Just think, Martha. Pythagoras, Euclid, and Sue Bird, the great math trio.
I can see it now. Your name in lights.
Oh, yeah.
Or at least in a math book.
What you saw in this scene were problems of measure, much as they occur around us every day. Here is a diagram of the wall that Bill wanted to cover with bricks. Now, this is really a 3-part problem. First, they had to determine the area of the surface of the wall. Then it was necessary to find out the number of bricks that it would take to cover it. The third step, once they had the other information, was to estimate the cost of the bricks. In the second part of the scene, Sue and Martha multiplied to get the number of jars of green beans they had preserved. Then they converted all of the canned beans to gallon. Remember, when adding measures, to keep like units in a column, much the same as when you're adding and subtracting decimals. In subtraction, much care must be taken when it is necessary to regroup. Here is an example of that process. Here is an example of Sue's shortcut. It's well worth exploring.
Bird residence.
Sue, this is Martha.
Oh, hi, Martha. How you doing?
Oh, I've got alligator problems. I belong to this club, and we make these toy alligators to send to children's hospitals, and I'm in charge of mailing them. Ugh.
So what's the problem?
The alligators aren't fitting into the mailing cartons, and I don't know what to do.
Well, that would be a problem.
Oh, come on, Sue. Can you come over? I'm really getting confused.
Okay, look, I'll be over there in a few minutes, okay?
Ah, great. Thanks a lot.
Okay, bye-bye.
Bye-bye. Thanks a lot for coming over, Sue. I feel better already. Sorry, this place is such a mess. I've been working all morning on this.
Well, I couldn't resist trying to solve an alligator problem, so fill me in.
These alligators fit into these boxes here, and the boxes are 4 inches around the end and 24 inches long, and I got to mail 24 of them.
Well, what are you going to mail them in?
You see that big box over there? That's what I'm going to mail them in.
Oh.
It's 24 inches wide, 8 inches deep, and 4 feet long, and the boxes all fit into it just right.
So what's the problem?
The post office says it's too big.
Oh.
They measure something called length and girth combined, and the total of those two measurements can't be more than 108 inches.
Well, how do they measure the girth?
They measured it around the smallest dimension, you know, that way.
Okay, the perimeter.
Yeah, I guess. Anyway, the girth of that big box turns out to be 24 plus 8 times 2, which is 64. Then you add the length, which is 48 inches. You get 112 inches. Now, that is only 4 little inches more than what they'll allow.
Well, maybe you can make 2 packages.
But it seems silly to put it into 2 boxes when one will almost do. And besides, postage is so expensive. My club is not rich.
Well, maybe we could rearrange them so you can mail them.
Think so? But it's the same amount of stuff no matter how you rearrange it.
Where's your math packet? There's some stuff in it that might help.
It's around here someplace. Oh, here it is.
Ah, good. There's a page in there about perimeters and areas. Ah, got it.
Great. So what do I do?
Okay, well, first you're going to have to rearrange these little boxes.
Okay. Now, rearrange them how?
Okay, well, first you're going to have to pile them up 3 high.
Okay.
Okay, 3 high.
Got that.
Okay, and now they're going to have to be 8 long.
Oh, yeah. Okay. But it still looks like the same size pile to me.
Well, it is the same size, but the surface may be different. Hey, why don't we measure the pile when it's stacked this way, okay?
That's a great idea. Okay. Now, it's still 24 inches wide,
Okay.
12 inches deep, and 32 inches long.
Okay, so then the distance around it, the perimeter, is going to be 24 plus 12 plus 24 plus 12, or 24 plus 12 twice. Let's see, and that is 72 inches. Well, let's see, that's girth in post office talk.
Yes, ma'am.
Now, we add that to the 32, and that makes the length of the girth and the length combined is 104 inches. Well, that's less than your 108-inch restriction.
It is. But I don't understand. I mean, how can you put the same amount of stuff into a smaller box?
Well, I think it says here that perimeter and area are related. Then it goes on to saying that the more nearly square a rectangle is, the greater the area in relationship to the perimeter.
Then what do you mean?
Well, remember the way you had the boxes arranged?
Yeah.
They were piled long and skinny. Now the way you have it, it's piled more like a cube, or as near as you can get, considering the shape of those alligators.
You think I'm going to be able to cut that box down to size?
Probably so.
Now, how did you know that that was going to work?
Well, I wasn't sure. But I do know that the shape of something does affect the area.
Oh, how'd you know that?
Do you remember when we were remodeling? Well, our utility room is 6 feet by 12 feet with a perimeter of 36 feet. And our bathroom is 9 feet by 9 feet. And that, too, the perimeter is 36 feet.
Yeah.
Well, are the rooms the same size?
Yeah, I guess so. I mean, they're just a different shape.
Nah, that's what I thought. But when I decided to put molding around the edges of the room, the amounts were the same. But guess what happened when I wanted to tile my floors?
I give up.
Martha, that's not a guess.
They're not the same size.
Well, not the same size in area, but the utility room area, or shall I say, the total floor space,
Yeah.
was 72 square feet. Now that's 6 times 12. But the bathroom is still 9 feet times 9 feet.
So the bathroom's area is 81 square feet. The areas are different and the perimeters are the same. Boy, that seems really strange to me.
Well, I guess it proves that equal perimeters don't cause equal areas.
Yeah, that's just like this alligator problem now. I mean, when we rearranged it, we changed the perimeter, but we didn't do anything to the area.
Yeah, but in this alligator situation, we're dealing with the volume.
Right.
Do you think you can fix up this carton now?
Oh, sure.
Oh, good. I'm going to take off.
Sue, thanks a lot for coming over. I really appreciate it.
Oh, anytime. See you later, alligator.
In a while, crocodile.
Did you hear those words? Length, width, perimeter, area, volume? Martha's problem with the alligators has to do with all those words. Let's look at the way the boxes were arranged before she called Sue. They were 2 boxes high and 12 long, 24 boxes in all. The perimeter of the end section, or girth as the post office called it, is 24 plus 8 plus 24 plus 8, or 64 inches. This can be thought of as 24 plus 8, 32 times 2, since 32 is halfway around the box. In this arrangement, the stack is 48 inches long. 64 plus 48 is equal to 112 inches, which is greater than the post office will accept. By rearranging the boxes so that they were 3 high and 8 long, the perimeter and length are now different, but the volume is the same. Look at this illustration. These figures have the same distance around them, yet the areas are different. Think about it.